All right, so I'm here with Suzy, the Aerodynamic Development Engineer. Congratulations on having a rock star title.
Yeah, thank you. It sounds
awesome.
pretty good, doesn't
it? It is, yeah. Tell me a little bit about what you do.
We work with the designers to change the exterior surface of the different vehicles that we're developing here for our future products to be more aerodynamically efficient and therefore improve fuel economy.
Right.
The design studio and the engineering team says this is what we want out of a car eventually, and everybody starts working together. And my piece of the puzzle is I take the surface and start working on it at the very beginning. We build a reduced scale model out of clay, 1/3 scale. And once we only have to do a couple of millimeter changes here and there, we actually build the full size, and that's when we do the real detail work. After we do the full size clay model, when we get the production type vehicles, then we test those, and we even do some refinement on the production type vehicles.
Oh, really?
Integration vehicles.
Okay.
Yeah.
So how has rapid prototyping really affected this change for you guys?
Rapid prototyping's been important for us because we can really get some detail work done. Back in the day when we used to do this, we would make different parts out of sheet metal. But it takes time. There's also the human element in that too when you're fabricating something. You know, I would sit in the wind tunnel and bend an air dam out of metal and, you know, tape it on with duct tape.
Wow, Suzy just bending the metal. All right, try that.
What rapid prototyping has given to us is that we know it's exact. A lot of times it can have the attachment points on it that the actual production part will have.
Okay.
So instead of having to put layers and layers of duct tape on something to keep it on at 100 miles an hour, we can put a couple screws in.
Because it's made that way.
This is an example of where we had two different parts made. First of all, the bottom of the fascia has a particular contour to it, so we know that it fits perfectly. It'd be really hard to bend a piece of metal in this shape. It would take you know, a significant amount of time. We can just have this made, and we can go with our criteria for ramp angle, how high this has to be to ground.
So you're not scraping it, getting it out of your driveway or whatever.
So we can have it actually cut to that. Then we can take it and go a little bit lower than that. Everything on the car affects everything else.
Right.
If you don't have mirrors on the car, then you're not going to get your deck lid in the right place, and it's going to affect your air dam. This is the full-size mirror that we would put on. In this case, we put this in and we started adding some clay to different parts of the mirror to see if we could improve the wind noise a little bit. In some cases, you can actually see the SLA through the clay. I mean, this is only a couple of millimeters. I mean, we're talking about just changing the sharpness of this radius.
That's mostly prototyped pieces, right?
It is, well, all prototype pieces. I'm proud to say that we made those vehicles in our shops upstairs. We did all the carbon work, body work, etc. Many of those parts were made in this lab, typically of this material. This is the material that affords sort of a greater level of durability. It's really intended to be more of a part with the exception of a prototype.
Right. This is an art. You have to be able to make everything work with given constraints, and it's just got to get complicated.
It's sort of a black art, really.
Okay.
You know, it's like
it's
a little bit of,
it
is. It's a little bit of magic. We joke about the wind tunnel gods, and you know, can you sprinkle some drag dust on it? Because it's almost a little bit of luck. You know, you do the job for a while, you get the experience, you know what parts to work on, you know what's going to affect something else. You really just kind of try to find the perfect combination of everything, and then once you get there, you're like, okay. Don't
no one move.
Touch it.
No one move, right?
Yeah, make this the high volume and print.